Claude just changed how you work. This was not a single announcement. It was a month-long quiet revolution. Anthropic shipped feature after feature, and the sum of it is this. AI is no longer something you sit down to use. It's something that works while you live your life. But before we dive in, did you know that 65% of you listening and reading are not subscribed to our socials? Come on, guys, hit that follow button and collect our episodes on pods.media. Thanks, everyone.
I mean, that really is the perfect way to frame it, the quiet revolution.
We're unpacking this massive shift in how you're going to interact with your workspace.
Yeah, it's a completely new paradigm.
It really is, because over the last month, Anthropic has rolled out this series of, well, seemingly disparate features for Claude. But when you step back, when you look at the whole architecture of what they've built, it forms a cohesive new reality.
Exactly. We are officially leaving the era of AI as just, a simple chatbot tool.
Yeah, the old way of doing things.
Right. If you look at the standard model for the last few years, it's been highly transactional. You sit at a physical desk, you open a browser tab, and you type a prompt.
And then you just sit there and wait for it to type back.
Exactly. You wait for the output, and then you manually act on it. It requires your absolute, undivided physical presence.
But this new model is, well, it's always on.
Always on, always running, always reachable. We're migrating from a localized tool that you operate to an environment that operates alongside you.
Which fundamentally changes the bottleneck, for everything.
It really does.
Because if AI is no longer just a text box you sit down to type in, the very first physical barrier to break is the desk itself.
The physical workstation.
Right. We have to untether the intelligence from the workstation. And that brings us directly to the new remote control feature for Claude Code.
Which is such a critical first step. And the underlying architecture of how they achieved this untethering, that's what makes it actually viable for enterprise environments.
Yeah, let me lay out the basic mechanics for you guys listening. With remote control, Claude Code can now essentially follow you when you walk away from your keyboard.
Right, like a persistent session.
Exactly. So let's say you kick off a massive, complex refactoring task in your terminal on your desktop computer. You can literally walk away, head to a coffee shop, and pick up that exact same session right from your phone.
But we need to pause here and look at the mechanism.
Oh, for sure. The security aspect.
Because anyone dealing with proprietary code or sensitive data is immediately going to ask about security. When you access this running session from your phone, your files are not being uploaded to a central cloud server.
Right, which is huge.
It's massive.
Yeah.
Your data, your local development tools, your MCP servers, they all stay entirely local on your host machine.
Okay, let's unpack this, because for anyone who might not be deep in the weeds of AI infrastructure, an MCP server or model context protocol is basically a secure, localized translator.
That's a great way to put it.
Yeah, so it allows the AI to query your specific private databases or read your local GitHub repositories without ever uploading that massive amount of data to Anthropic's cloud.
Exactly. It's an open standard that keeps your proprietary context completely locked down.
So it's safe.
Very safe. So when you are out at that coffee shop, your phone is not processing the heavy lifting, and Anthropic isn't hosting your corporate database.
Right, your phone is just like a remote control.
It's simply acting as an encrypted, secure tunnel, a window into the session that is actively running on your local secured machine.
Developer Peter Levels had a great quote about this. He said, "It is like an SSH session, but one that actually makes sense to use."
Which is so accurate.
But I have to push back a little here, because historically, SSHing into a desktop from a mobile phone is a notoriously miserable experience.
Oh, it's the worst.
Right. It's tiny text. You're trying to type complex bash commands on a mobile keyboard, and one typo ruins everything.
Yeah, you hit the wrong key and suddenly you're in the wrong directory.
Exactly. So how does this actually solve that friction?
It solves it by completely removing the need for you to type the commands.
Okay.
You aren't logging in to blindly navigate a file directory manually. You are logging in to converse with the entity that is navigating the directory for you.
So it's less like remote controlling a computer and more like texting a colleague who is sitting at your computer.
Precisely.
Imagine you have a hyper-competent executive assistant physically sitting at your desk.
Yeah.
You are out at the dog park. You text your assistant an instruction.
Right, just a quick message.
And they turn to the monitor, do all the heavy lifting, the typing, the file searching, the compiling, and then they just text you back a summary when it's done.
Yeah.
Your phone is just the walkie-talkie.
That's the perfect analogy.
But this leads to a huge question, because Dispatch isn't just described as Claude on your phone. It is explicitly called an orchestrator.
Yes.
How is an orchestrator fundamentally different from, a mobile chat interface.
That distinction is everything, actually. A standard chat interface is a linear one-to-one conversation.
Right, back and forth.
Right. But an orchestrator manages complex, simultaneous, stateful systems.
Okay, what does that look like in practice?
Dispatch allows you to maintain one single persistent conversation thread on your phone while it manages multiple co-work sessions running in parallel on your desktop.
Wait, I need to understand the how here. How does one text from my phone spin up parallel work without completely crashing my local machine or creating some tangled mess of conflicting code?
It works through agentic subtasks.
Agentic subtasks. Okay.
Yeah. When you send a broad mission from your phone, say, update our database schema and migrate these 3 endpoints, Claude receives that goal and acts as the project manager.
Oh, wow.
It writes a plan, and then it literally spawns isolated parallel terminal sessions or containerized environments for each subtask.
So it's breaking down automatically.
Exactly. It assigns one sub-agent to the database schema, another to endpoint A, and another to endpoint B.
And it monitors all of them simultaneously.
Yes, it is constantly reading the output logs of those parallel sessions.
That's wild.
If the agent working on endpoint B hits a syntax error, the orchestrator sees the error in the log, analyzes it, and attempts to fix the code automatically.
Without bothering you.
Right. It only sends you a push notification when the entire multi-threaded job is complete, or if it hits a roadblock that actually requires a human executive decision.
That parallel processing aspect, that completely redefines leverage.
It changes the whole equation.
There's a specific workflow example from the rollout that is just mind-blowing. A user tracked their time using Dispatch.
Oh, the 25-minute one?
Yes. Over the course of an entire day, they spent a total of just 25 minutes actively giving directions to Claude from their phone. Just quick voice notes and text approvals while going about their life. In response to those 25 minutes of input, Claude executed over 3 hours of parallel, verifiable work on their machine.
What's fascinating here is how that ratio alters the physics of your workday.
Oh, totally.
When you trade 25 minutes of management for over 3 hours of execution, you aren't just speeding up your workflow. You are fundamentally transitioning your role.
You're stepping off the assembly line.
Exactly. You are no longer the laborer whose physical typing speed dictates the output. You have become the director orchestrating the outcomes.
But hold on, I have to play devil's advocate for a second.
Sure.
Because 25 minutes of prompting for 3 hours of output sounds incredible on a marketing slide.
Yeah.
But how much of that 3 hours is Claude just hallucinating in a loop?
That's a very fair question.
Right. If I'm not at my desk watching the terminal, how do I know it's not quietly deleting a production database because it misunderstood a prompt?
This is exactly why the localized MCP and the orchestrator model are so crucial. It isn't running blind. The orchestrator is designed to validate its own work through your local testing environments.
So it tests itself before it tells you it's done.
Precisely. Before it ever pings your phone to say, I'm done, it has already run your local test suite. If the tests fail, it reads the failure stack trace, iterates on its own code, and tries again.
So it's catching its own hallucinations.
Yes. It is bounded by the exact same local guardrails you set up for human engineers.
Okay, that makes sense. You're giving it the keys, but it's driving on a track with guardrails.
Exactly.
But untethering the AI from your desk only solves half the problem. Because if the system is still sitting there waiting for you to send a text from the dog park, you are still the ultimate bottleneck.
Right, you still have to initiate the action.
Exactly. The real shift happens when the system stops waiting for your commands altogether. What happens when the AI just starts reacting to the world around it?
And this brings us to the introduction of channels and event-driven architecture.
Here's where it gets really interesting. Because Claude Code can now react to external events via platforms like Telegram or Discord.
Yeah, which is a massive leap.
It is. You can pipe live external events directly into a running Claude Code session. We are talking about feeding continuous integration failures, live monitoring alerts, and raw webhook payloads directly into the AI. But I gotta ask, are we just wiring Claude directly into the nervous system of our software environments?
Yeah.
Isn't it wild that it responds through those same channels without us clicking a button?
Well, the analogy of a nervous system is actually highly accurate here.
Okay.
Let's look at how a webhook payload actually functions. A webhook is essentially an automated message sent from one application to another when a specific event happens.
A server crash?
In a traditional setup, if a server goes down, a monitoring tool fires a webhook that triggers a PagerDuty alert on a human engineer's phone.
And ruins their dinner.
Exactly. That human has to stop what they are doing, open their laptop, log into the server, pull up the raw error logs, parse through the JSON data to diagnose the problem, and then write a fix.
It's awful.
It is a highly manual, highly reactive loop.
With channels.
With channels, you bypass the human triage entirely. You route that webhook payload directly into Claude's secure running session.
So Claude gets...
Yes. The system feels the pain of the error via the webhook, digests the JSON payload to understand the context of the crash, uses its terminal access to automatically grep the relevant logs, and can propose or even execute the fix.
Right in that same Discord channel.
Exactly. All while you are entirely focused on a different project, we are creating a reactive, autonomous ecosystem.
It effectively turns the AI into an autonomous immune system for your infrastructure.
That's a great way to describe.
But they didn't just give Claude the ability to react to emergencies. They also gave it a sense of time.
Yes, the scheduled tasks capability. This pushes the paradigm even further because Claude now operates on a chronological clock, not just on a demand cycle.
The practical applications of this are wild.
Oh, they are everywhere.
You can set it to synthesize morning briefings from your company's communication channels before you even wake up. It can handle your weekly database scrub automatically every Friday at midnight. It can sweep your local error logs every 4 hours in the background. My absolute favorite example, though, generating pull requests from approved issues overnight.
Let's explore the mechanics of that overnight PR generation, because it really highlights the decoupling of human time from computational time.
Right. So imagine you approve a bug fix ticket in your project management software at 10 p.m. You close your laptop and you go to sleep.
You're done for the day.
Exactly. But because Claude is running locally on a schedule, it wakes up at 2 a.m., sees the approved ticket, reads the associated code base, writes the fix, runs the local tests, and submits the PR to your repository.
By itself.
By the time you wake up and pour your coffee at 7 a.m., the work is already waiting for your...
Human beings require rest, right? We operate in shifts. But by integrating scheduled tasks into an untethered local environment, your workspace is continuously pushing projects forward asynchronously.
Yeah, the work literally does not wait for you to wake up.
No, it doesn't.
It's the ultimate night shift worker that never needs a coffee break. But as I'm looking at this entire ecosystem, the remote dispatch, the webhooks, the scheduled tasks, a glaring question comes up.
What's that?
It is fantastic that Claude can manage code and read structured JSON from webhooks and run scheduled terminal commands for modern software development. But what about the rest of the world?
Legacy systems.
Yes. How does this entity interact with software that doesn't have neat APIs or clean webhooks or open terminal access?
That is the exact friction point that has bottlenecked enterprise automation for decades.
It's a huge problem.
It is. The global economy runs on an astonishing amount of proprietary, closed-off, or incredibly legacy systems that simply refuse to communicate with modern software.
Enter the computer use feature. And if you listening haven't seen the demo for this yet, you are in the minority.
Oh, absolutely.
When Anthropic dropped the preview of this capability, the metrics were staggering 40 million views in just 16 hours.
Which is an astronomical metric for a B2B software feature update.
It's unheard of.
It speaks to a deep, visceral recognition of what this capability actually implies for the daily reality of the average knowledge worker.
It went viral because it legitimately looks like magic. But let's break down a how, because it isn't magic.
Oh, it's very methodical.
Claude can now literally control your mouse, your keyboard, and your screen, but it isn't hacking into the back end of your applications. It uses advanced vision language models to look at the pixels on your monitor exactly the way a human does. It works on literally any application with zero special setup and absolutely no native API integration required.
For decades, software engineers have spent billions of dollars trying to build brittle bridges between incompatible systems.
Oh, the custom integrations.
If application A needed to push data to application B, you had to write custom integration code. If application B was a 25-year-old legacy accounting software without an API, you were out of luck.
A human had to manually copy and paste the data. So what does this all mean? Instead of some sci-fi trope of a ghost in the machine hacking the mainframe, think of it more like giving the AI a pair of virtual eyes and a robotic arm.
That's a good visual.
It takes a screenshot of your desktop, apps a dense grid over that image, and visually identifies the UI elements. It sees the submit button, calculates the exact X and Y coordinates of that button on your specific monitor, and then executes a command to physically move your cursor to those coordinates and click.
It's just interacting with the UI.
You wanted to configure your local clunky 3D printing software. Done. You wanted to do your morning email sweep across 3 different proprietary desktop apps. It can do it all just by looking at the screen.
It's transformative.
But again, I have to be the skeptic here. A vision model interpreting pixels sounds incredibly fragile.
Can be.
Like, what happens when an unexpected pop-up appears? Or what if a software update slightly moves the submit button 5 pixels to the left? Doesn't the whole automation just break?
If it were a static macro, yes, it would break immediately.
Right, like those old reporter tools.
Exactly. But this is where the intelligence of the vision model comes in. It is not executing a blind, pre-recorded path. It is taking continuous screenshots to verify state.
Oh, so it's constantly checking its environment.
Yes. If a pop-up appears, the vision model takes a new screenshot, reads the text on the pop-up, understands that it is an obstruction, calculates the coordinates for the X to close the pop-up, clicks it, and then recalculates the path to the original submit button.
That is why.
It is a dynamic, synthetic human operator.
It's navigating the visual chaos of a desktop environment in real time.
And if we connect this to the bigger picture specifically, if we combine this computer use capability with the dispatch orchestrator we discussed earlier, we arrive at the ultimate workflow scenario.
Okay, lay it out for us.
Imagine the causality here. You are out at dinner, you pull out your phone, and assign a complex multi-app data migration task via dispatch.
While looking at the menu.
Right. Back at your office, on your physical machine, the computer use feature wakes up. The AI physically takes control of your desktop. The cursor starts moving across the screen on its own, clicking through legacy applications, typing out data into forms, closing pop-ups, and navigating visual interfaces.
It's literally doing the busy work.
You finish your dessert, you come home, and the work is completely finished on your physical monitor.
The invisible night shift strikes again, but this time it's using the exact same steering wheel and pedals that you use.
I guess that's exactly it.
And that brings us to the synthesis of everything we've unpacked today. Because none of these features, the local remote control, the dispatch orchestrator spinning up parallel subagents, the channels digesting raw webhooks, scheduled tasks, or the viral visual computer y'all, none of them actually matter in isolation.
Oh, they don't.
They aren't just a grab bag of random monthly updates.
No, they're inherently interconnected architectural pillars. When you distill the core insight from this month-long quiet revolution, you realize that Anthropic has shipped a single, highly coherent idea. They have architected a reality where AI is now always on, always running, and always reachable from wherever you are, capable of interfacing with both the deepest backend code and the most superficial visual interfaces.
You are no longer operating a tool.
You are delegating to an entity that simply does not stop when you do. That is the fundamental takeaway for anyone trying to understand this shift.
The whole mental model has to change.
It does. The mental model of using AI to help you type an email or fix a line of code is obsolete. We are now firmly in the era of managing AI as an autonomous, persistent resource.
It is a profound shift in how we define our own utility and speed in the workspace. And it brings me to a final thought I want to leave you with today.
Let's hear it.
As you absorb all of this, as you think about secure mobile tunneling, the scheduled overnight PRs, and the virtual eyes and hands clicking your mouse, consider this. If our relationship with work shifts entirely from doing tasks to delegating to an entity that never stops, what happens to the concept of our own downtime?
That is the big question.
If your machine can seamlessly sweep errors, navigate legacy software, and write code while you're asleep, will the future expectation be that your digital avatar is producing tangible value 24/7 when you aren't physically present?
This raises an important question about the boundaries we will need to establish. When the speed limit of productivity is no longer tied to human typing, the expectations of output will inevitably recalibrate.
Exactly. The bottleneck is no longer your hands. It's your imagination and your management. Definitely something to chew on as you look at your computer screen tomorrow morning. Thank you so much for joining us. Keep exploring the boundaries of your newly automated workspaces. Keep asking the hard questions, and we will see you next time.